Very good afternoon, everybody. We welcome you all to today's webinar on 3D printing with precious metals. We are very thankful to Mr. Shah for having this webinar for us today. During the session, in case if you have any questions, you can post it in the questions panel and we would be happy to answer them. Now, I hand over the presentation to Mr. Shah to take it forward from here. Over to you, sir.
Thank you, Swapnil. Good afternoon and welcome to the webinar on 3D printing with precious metals. My name is Rootesh Shah and my company, Innovarium, provides end-to-end 3D printing solutions to jewelry manufacturers and retailers. Before we begin this session, a quick word on 3D printing. Of late, 3D printing has become ubiquitous in the media, making this a topic that most of you have heard of. However, much of it is at variance with the actual 3D printing process. With this presentation, I hope to address some of those points. Having said that, it is undeniable that 3D printing is an idea whose time has come, particularly with metal 3D printing. It stands along artificial intelligence, robotics, and blockchain as the technology of the future. Several governments across nations, namely USA, Singapore, Japan, have invested hundreds of millions of dollars to encourage 3D printing. And private companies, for example, GE, has invested close to $1 billion in 3D printing, and closer home, companies like Wipro are doing pretty much the same. And with very good reasons. 3D printing is viewed as a technology that will bring parity in manufacturing costs and bring manufacturing back into the developed countries. It is expected that 3D printing will erode the cheap labor leverage that the developing countries have been using for decades. Further, 3D printing will bring manufacturing closer to the customer. The implication being that there would be smaller production runs, customization, and fast delivery times in days, not weeks, at minimal costs. And this would be a norm, not exception. Third, 3D printing will democratize manufacturing. This is the most important point, I feel. With 3D printing, jewelry can be manufactured with smaller factories, with lesser capex. Combined with this, 3D printing manufactures high quality parts with faster delivery times, and it allows efficient customization. This opens up in-house manufacturing opportunities for retailers, traders, standalone jewelers, all those people who had to depend on other manufacturers before. 3D printing is expected to make design capabilities more valuable than manufacturing strength. With that, I will begin this session. The topics I'm going to discuss today are what is 3D printing, 3D printing technologies of precious metal, 3D printing manufacturing ecosystem, pre-build and post-build considerations, and hybrid manufacturing. But let's start with the beginning. So in the beginning, manufacturing in precious metals was done by artisans, which means it was done by hand, there were no machines. So it looks something like this. But what did that mean? The pros of this kind of manufacturing was it had imaginative designs. It was design-led manufacturing. And I'll come to this point a bit later on. There were bespoke products. There was uniqueness in experience and ownership. Multiple products were made by the same manufacturer. There was lower capex, lower inventory management, lower wastage, and higher margins. But what were the cons? There was no quality control. Products were very expensive. Delivery was lower. It was localized manufacturing, which means the best resources were never used. It was inefficient way of manufacturing, and it was low volume. Then, steam power was discovered, and we had the first industrial revolution. With cars coming in, Henry Ford invented a process called assembly line. An assembly line means, well, you know what, let me just show you. happens in an assembly line. Even today, in spite of all the modernization, we still use assembly line manufacturing. So, what are the pros? Now you have uniform quality, cheaper products, faster delivery, you have wider geographical markets, and efficient use of the talents and resources, and you can now produce higher volumes with the same quality levels. And what are the cons? Now it's manufacturing-led designing. You have standardized products. There's no uniqueness in ownership or experience. The manufacturing categories taper out for each manufacturer, higher capex, higher inventory costs, hence more working capital, and as you know, lower margins. So, what is our wish list? Obviously, all the pros in the pre-industrialized way of manufacturing and industrialized way of manufacturing. And of course, we don't want the cons of either of them. Is that possible? Of course it is. Well, if not all, then most of it, it is possible now with 3D printing. However, that requires strategy and a manufacturing ecosystem around the 3D printing technology. This strategy is the pivot around which you can create your manufacturing ecosystem for 3D printing. So what is 3D printing? 3D printing is a manufacture of end-use component using additive layer manufacturing process. Let me come back to that point. Additive layer manufacturing. Ever since man started manufacturing, they have used subtractive manufacturing, which means what? You take a material of choice and then you pare it down to the design that you require. So for example, if you're going to make jewelry, you take a bigger piece of gold or platinum or whatever material of choice and then cut it, mold it, drill it, grind it, whatever to the design required. And it was same probably for every other industry. So for thousands of years, man had used subtractive manufacturing. 3D printing is completely opposite. It is additive manufacturing, which means the 3D object or the end-use product is manufactured layer by layer till you get the object which is for end use. The printing process is automated. It takes a two-dimension layer from the computer data and rebuilds that into a 3D solid object. So from byte to atom. Simply put, feed the design into a machine, press the print button, and the object is manufactured layer at a time without human intervention. Means no forging, casting, or any of the conventional processes. Of course, this is a simplistic way of putting it, but this is a concept. As we go along, I'll explain further. So how does the 3D printing process work? There are several technologies within the 3D printing umbrella. However, this is the common process throughout. To start with, you have a 3D geometry file, which is normally known as a CAD file in the jewelry industry, and which is fairly ubiquitous. From the CAD file, there are software that generate a .stl file, which is a file which is readable by the machine. The parts need to be oriented so that optimum efficiency is used for the machine. Generate support structures, and support structures can be generated by the machine and the software itself, or in case of metal 3D printing, you need special technicians to do that. There are software within the machines that will slice the files and supports horizontally. The material is consolidated and cut layer by layer. The machine is indexed up or down, one layer at a time, and the machine starts the layering process, which is repeated for thousands of times till the 2D design, which is read by the machine, is converted into a 3D printed object. So, let's get a comparison in a nutshell. Say in an investment casting manufacturing, you have the concept, followed by the CAD design, followed by a master mold. From the master mold, you'd make a silicon or a rubber mold. You would shoot wax piece inside that, make a tree, put it in casting. After the casting, It comes a semi-finished piece which you polish, grind, whatever post-process is to be done, and then you have the final piece. With 3D printing, concept, CAD, semi-finished model, final model. So, what materials are being used in 3D printing? Organic, ceramics, polymeric, which are plastics, and metallic. The interest to us is the precious metals, so gold, platinum, silver is being used. In gold, 18 karat is the material of choice as it stands right now. 14 and 10 are in R&D at this point of time. And who are using this? Car companies, defense, large production factories, avionics, medical, and consumer. These are some of the products being made. This is bespoke jewelry made in titanium. Critical parts made for high-tech industries. So why all this fuss about 3D printing? Well, the creative commerce industry, which is the jewelry industry, is a design-centric industry. Each market is unique. Material loss is a very big factor to our bottom line. Customization is the mother lode which everybody wants at a minimal cost. Lead times from concept to delivery is extremely crucial. Inventory costs affects our cash flow dramatically. People are asking for lower quantities per design. They're asking for more design variation, more design iterations per design, and our product life cycle is shortening. For each of this, 3D printing could be an excellent leverage. So let's look through the different types of 3D printing technologies available for printing in precious metals. The first one being SLA. Most of you probably know this because this has been ubiquitous in the jewelry industry for past decade and a half. Here, a photopolymer resin is being used and an ultraviolet laser is used to draw on the resin to create the design that is required. But let you go through a video that actually explains this. Off the printer and then show a customer. When we were deciding which printer we wanted to purchase, Envision Tech was a clear-cut winner. We went with Envision Tech for factory for minis. We've been very happy with them, purchasing more, it seems like on a yearly basis now. We direct cast the PIC 100 green material, in my opinion, one of the best materials that Envision Tech offers, especially when it comes to the casting process. Customer will upload or send us selected model all the way to broadcasting exceeds customer expectations when it comes to delivering high quality products. So what are the advantages and challenges for SLA printing? Well, faster cycle time to make the master mold, a very high level of accuracy as compared to the traditional way of making molds. It's an open softwares are available. These are low-cost printers, making it very easy for even the smallest of jewelers to buy these printers. What are the challenges? It is low volume and primarily for making molds and not production. It does not greatly reduce operations on the manufacturing floor, except for the mold making part. And well, of course, the Silver Master still needs to be made from the resin. But this is a good 3D printer for design validation. The next one is the digital wax printing. Instead of the resin now, you have digital wax, which is a castable wax. This changes the method of 3D printing now. Secondly, the 3D digital wax machines have a higher volume, which means that now you can take out production batches from the 3D printer. All the designs are digital, so molds are not required. All your molds are digital. Design iteration is virtually free of cost. Let me show you a video for that. So the advantages and challenges of digital wax printers: reduces the process of master mold, silicone mold, flag shooting, etc. Just 3D print your designs in volume and send it for casting. Just brilliant. The digital molds eliminates the need to store physical molds. The high degree of complex designs is possible with digital wax machines. The material is directly castable. You have an extremely high quality of product offering. The supports which are generated by the machines are dissolvable as seen in the video, and it's extremely easy to remove. And the post process is similar to the investment casting, which makes it very, very easy to integrate within the existing system of operations. The challenges: there are material limitations. You can't cast in platinum or titanium. You can't make linked, assembled, or nestled products. So products like bracelets or links with chains are extremely difficult to make. There is uneven surface roughness in case of very, very complex designs, which are very, very difficult to post-process. The internal cavities and edges are visually very rough and are very, very hard to polish. And it's a high maintenance equipment. And last but not the least is direct metal laser sintering. or DMLS. It is also called selective laser sintering or SLM, which is selective laser melting. This is the one I'm most excited about. Now, the difference between SLA and digital wax with the metal printing is that the SLA and the digital wax printers can be easily integrated into the existing manufacturing ecosystem, because after a certain point, it still uses the same manufacturing system which has been used traditionally. DMLS eliminates all that, because with DMLS you print directly on metal. Hence, it eliminates even the casting process. Straight away, the 3D printer prints on a gold, platinum, silver, or a titanium powder. The parts are made and they straight go for post processing and final shipping. So how is it done? In the same probably way. It's CAD file, which is turned into an .stl file. The second part is extremely important. A technician works on the 3D model to create the support structures. In SLA and digital wax, the support structures were created by the software itself, and because of the nature of the material, they were self-supporting. Metal powder does not support itself. Hence, a specialized skill set is required to create a support structure. In addition to that, orientation of the design is also extremely critical. Once this build file is completed, it is the software, the design is sliced into thick layers by the machine. The DMLS machine uses a high-powered fiber optic laser. And inside the build chamber, the material of choice is there in the dispensing platform, and a recoater spreads the material in a 20 to 30 micrometer layer. The laser focuses its beam on the material, reading the STL file. It melts the powder in where the design needs to be solidified. Once the entire job is completed, the build platform is extracted and the parts are physically cut from the platform. And then the parts are post-processed as required. So let's see a video that demonstrates the entire process.
What's your emergency? I need metal parts fast. Fast? Yes, fast. How fast? Like tomorrow. Tomorrow, eh? formal cooling channels within tools and tooling inserts, as well as customized medical input. DMLS makes it possible to design internal features and passages that cannot be cast or machined. Complex geometries with multiple components can be simplified, eliminating the need for assembly. The lead time for receiving a traditionally tooled part can take weeks, creating a large bottleneck in the production process. DMLS produces parts in a matter of hours or days. Parts have excellent mechanical properties, high detail resolution, and exceptional surface quality. DMLS parts can undergo functional testing in the environment for which they were designed. Since DMLS uses most alloys, prototypes can be made out of the same material as production components. The ability to generate functional metal prototypes in short order radically impacts design processes, accelerating design cycles for time to market. The advantages do not stop at prototyping. DMLS is one of the few direct digital manufacturing technologies used in production, increasing design efficiency for technical applications. DMLS technology delivers unlimited potential for engineers to create previously impossible solutions, embracing a new era of design-driven manufacturing. Delivery from TPI prototype for the pressured engineer. TPI prototype? You guys are the best. Thanks a lot. Another happy customer.
So, what are the advantages of DMLS? DMLS can print in most metals and alloys, including platinum and titanium. So, for example, you can have hollow platinum and titanium jewelry. This has the ability to quickly produce unique parts because no special tooling is required, like molds and things like that, and parts can be built in a matter of hours. Since it's built layer by layer, it's possible to design internal features, passages that was impossible to do in casting, machine, or even 3D printing technologies like digital wax, or SLA technology. You can make extremely complex geometries. You can make assembled pieces, making the multiple components printing at the same time. This means the designs can be simplified to fewer parts at negligible assembly costs. Since DMLS can use most alloys, prototypes can now be a functional prototype made out of the same material as a production component. For example, a functional prototype can be printed in brass before commencing production in the precious metal. And DMLS does not require any special tooling or molds like casting, so mass customization and short production runs for complex designs are absolutely possible. And what are the challenges? It has a high capital cost. Well, in relative terms. It's getting disconnected. Got it. Disconnected. Alright, then we continue with that. Okay, so challenges of DMLS, high capital cost. Well, in relative terms, a few years ago, a machine would cost somewhere about 250,000 euros for precious metal machines. It has come down to less than 100,000 euros. And the costs are going down. The system needs to be operated in controlled environments because gas is used in the vacuum chamber. Volume production run is not possible. We can have short batch production, but not volume production as in digital backs. It requires additional equipment for post-processing, especially to take out the support material, although these post-processing equipment is not very expensive. Very importantly, it requires separate skill set to create designs for this technology, because far more complex and unique products can be created, and support system is an integral part of designing. The printed supports cannot be reused, so typically these supports are melted to recover the metal. So, one of the key philosophy of direct metal printing is that it is not manufacturing-led system. In any other way of manufacturing, the actual manufacturing or the fabrication part is the key, and the design, CAD, product planning, merchandising, everything is centered around the fabrication part. The limitations or the opportunities that the fabrication provides are around which the design, product planning, material handling, everything takes place. With GemAtlas, it is design-led manufacturing, which means design is the key. Manufacturing, inventory, merchandising, product, CAD, everything centers around design. That's coming back to my first slide, in which I mentioned that the 3D printing allows design to be value added rather than the manufacturing strength. And this is the key to 3D printing in direct metal. To have a short analysis, while printing in direct metal, there are 4 aspects to it. If you're prototyping or production, and when I say production, it means short batch productions. The part orientation, as in what is the geometry of the design, what are the internal features, so on and so forth. The file preparation, which includes the support structure, the orientation of the part, the platform build, and last, the process, which means what happens after the piece is printed and the process in its entirety. I personally believe that 3D printing equipment or the 3D printing machine is only one link in the overall 3D process chain. Design and post-processing, while time consuming, are extremely important to achieve optimum part quality. A word on supports. Supports are extremely critical while printing directly on metal. And supports actually have their own functions. Namely, it supports the melted surface, it dissipates heat from the surface, and it prevents the surface from deforming. And it's a necessary evil. I've also seen that many designers who have used the DMLS have actually incorporated the support structures within their design, creating a separate design element, which is a very clever way of using the DMLS process. So let's go ahead and see a video of actually printing gold parts. clears up and gives you insights into the 3D printing technologies which can be used for precious metal. But the next question is, how do you choose the right 3D printing technology for your operations? Well, for that, I would use some of the metrics for deciding that. Number one is, what is the usage, or what kind of designs you would like to generate? What is the quality level? What are the kind of volumes? What is the choice of materials? What is the cost involved? And of course, at what price and margins will you be able to sell? SLA, of course, is the choice if you are going to go for very low complexity without any customization. It is a very low investment, and it could be used for mass manufacturing, and the margin strategy could be a cost plus margin. The digital wax printer gives you semi-customized, a very high degree of complexity. You can make hollow gold and silver products, take special orders, special collections. It's a medium investment. A smart manufacturer could have product-wise market share depending on the design capabilities, and it could be an incremental margin strategy. DMLS should be used for customized jewelry with very high degree of complexity, with high iterations per design. If you have assemble or nestle pieces, as in bracelets or chains and things like that, or for hollow platinum and titanium products, here it's a high investment relative to the digital wax or the SLA printers, but a manufacturer who can combine the existing technology with DMLS can get a very high market share, and the strategy could be a value minus margin strategy. So, having seen what kind of 3D printers are available for printing in precious metals and how to choose them, it's important to have a strategy and to create an ecosystem around 3D printing. As mentioned earlier, just the 3D printing machines are not going to do the trick. It's how a manufacturer creates a focused manufacturing system around 3D printing. So the strategy will decide what kind of markets you will cater to, which in turn defines what kind of products you're going to make, which also decides what kind of 3D printing technology you will buy. So the questions to ask for acquiring a machines are, which printers will you acquire, where will you build them, for which material, how do you define your product strategy, how will you hire people, and how do you create processes. That's one part of the ecosystem. The second part is that once you have the physical part of the manufacturing system, how do you build teams around 3D printing technology, who spearheads it, how do the teams communicate, and how do you create systems to enable teams to respond faster to the market feedback for the designs which could be 3D printed. But most importantly is that every part of the team, every member of the team needs to understand how 3D printed could be leveraged. Hence, communication is very, very important. To create a very profitable roadmap, a 3D printing manufacturing ecosystem has to be based on all sound strategy. So typically, this is how an ecosystem would look like. You would have a 3D printing leader who would have all the critical information and has all the who is the pivot around which the entire system operates. Then you have the designing team with its functions, the R&D team, the CAD team, manufacturing, post-process and QC, sales and marketing team. Now, traditionally, there would be a lateral way of working, in which each department works in a silo and really doesn't know what the other department is doing. With 3D printing, that doesn't work. Each member of each team needs to understand what is happening. Hence, the communication would be all around. All the design teams would communicate to the leader as well as to each other. And why so? Because each member of the team needs to understand which criteria is being leveraged when using 3D printing. Is it the material cost? Is it the design? Is it the tooling cost? Is it the assembly? Is it the lead times that you're addressing? Is it the customization? Is it the low quantity but high quality production? Or is it the just-in-time inventory? 3D printing can address all these issues provided each member of the team and all the departments understand the potential of 3D printing in which to leverage these parts. It is vital to create an environment to enable the teams to view 3D printing as a complementing technology and not a competing one. And most important is the leadership, who should work continuously to integrate 3D printing within the manufacturing ecosystem. Only then 3D printing is most effective. So let's go to pre-build, post-build, and hybrid manufacturing. Pre-build and post-build refers to those part of the production processes which do not have anything to do with the fabrication of the 3D printed parts, which means everything that happens before the machine prints and after the machine prints. The total time taken for the pre-build and the post-build is 65 to 70%. Hence, it's quite imperative to think through the pre-build and the post-build in terms of the complexity of the geometry, which is your design, what kind of material you're using. Is it a more valuable material like gold or silver, or more harder material like platinum or titanium? What kind of quantities? Is it a prototype? Is it a short batch run? What kind of 3D printing are you using? What kind of post-build assembly is required? Is it required or not required? The number and type of post-processes which are required, and cost to time ratio versus the expected margins. And hybrid manufacturing is actually combining your existing strengths with the strengths of 3D printing to create newer products and newer markets and to build very high entry-level barriers. And hybrid manufacturing, if used well, creates new business opportunities. And of course, an opportunity for higher margins as well. 3D printing allows new product categories and designs previously impossible to make. So in terms of teams, this is how it would be segregated. Pre-build will have designing, research and development, CAD data preparations, sales and marketing because they would give the market feedback. Post-build provides post-build processing, assembly validation, QC, R&D, cost and pricing, logistics, sales and marketing. And build has manufacturing and material management. And in terms of functions, pre-build and post-build, as you can see, have the maximum amount of functions. Build has minimum. And that would give you an idea that a 3D printing ecosystem has to have a strategy. After doing all that, it's also vital to plan your products for 3D printing. So as a thumb rule, if a product can be done effectively with the conventional way of manufacturing, do not use 3D printing. However, if you do find that your designs are inefficient to produce conventionally, or require faster lead times, or require a low weight, then 3D printing is your choice. Within that, search for the cheapest 3D printing technology that can satisfy your orders. Once you've decided on 3D printing technology to be used, it's best to validate in non-precious metals before going into production in precious metal, especially with DMLS. As a thumb rule again, I would have 3 stages of trial run: alpha, beta, gamma. The alpha is typically on the computer at a data stage, where the data, the CAD file and the build platform is validated by the design, the R&D and the manufacturing team. All that information is collected and that data is fed into the beta stage. Now, by this time, a lot of your designs would be either be rejected or needs to be modified. At the beta stage, you have the first trial run in the non-precious metal like brass or bronze. This is for the functional and the physical verification of the design. Again, the part is then studied for and validated for the design, look, feel, the support structure, what post processes need to be done or should be planned, the expected final qualities, and the tolerances, and the repeatability of the design. Sometimes it's great to have a complex design, but extremely difficult to have repeatability of the design. And that gets eliminated at the beta stage. The third is the gamma stage, which you actually make one piece in the precious metal to get a final validation of the 3D printed piece. This will help in costs, it will ensure error-free runs and design optimization and efficient machine hour cost. So finally, let's have a little bit of case study in the pre-build and post-build and in hybrid manufacturing. So this is a part of a earring which needs to be 3D printed. Now, if I needed to print this in gold or silver, I'd probably use a digital wax machine. Again, it depends. If I want to have a volume run, then it's digital wax. If it's a one-off piece and it's a low price piece, then probably I would make a piece 3D printed in the SLA and then make a master mold out of it. As you can see, the red parts are the support structures, and these are the design notes. It says this is a good design and suitable for DMLS. If I were to make in, say, platinum or titanium, it's hollow and it has self-supporting angles, so the minimal number of supports are needed, which is great because then the post-processing costs are lower, and the wall thickness is about 0.5 mm. This is a result of hybrid manufacturing, wherein the main body is made out of titanium using the DMLS technology. The gold part is casted. The diamonds in the titanium are hand set. Hence, we are using 3 different manufacturing technologies to create a hybrid manufactured product. Second is the case of gold ring, which has assembled pieces. Each of these pieces parts are rotating parts. This design with these kind of support structures is the most inefficient way of manufacturing, because to cut these support structures and to do the post-processing is extremely cost ineffective. The design was then made in this form, wherein you had the minimal amount of supports required. These parts are now do not require supports because they have been used using the rules applicable to the DMLS. And the final part is this. This part has come out of the DMLS machine before the post-processing. So, in summary, it is possible to get the best of handcrafted, customized products with the best of mass manufacturing using 3D printing. Strategy is vital to 3D printing manufacturing in precious metals. It decides which printing technology to invest in, which products, what kind of margins, and the people to invest in. 3D printing is design-led manufacturing, where the pivot is the design, data preparation, and post-processes. Teams and the interaction is as important as the technology and the 3D printing machines. Pre-built and post-built processes are the main pillars of 3D printing. Supports are necessary evil. The trial stages with non-precious metals during development is an efficient way to produce repeatable designs in precious metals. And hybrid manufacturing is a powerful process that combines the best of existing manufacturing resources with 3D printing, creating high entry barriers and opportunities for margins and market share. Thank you for your attention, and you can contact me on these contact details. I'm ready for any questions that you may have. Thank you for your time. So this, so how do I answer this?
Read out the question.
Okay. All right. So Mr. Deepak K has asked question, is the surface out of the machine acceptable for finishing? Okay. So I'm assuming that Mr. Deepal is asking about the DMLS process. No. My answer is no. If it's out of the machine, it is not acceptable as an end product, but it is, there are post processes available which can finally finish the product and which can be shipped out to the end customer. I hope that answers the question. 3D. The next question is from Viprika Jain. She says 3D printing technology is powerful, but how can we widely apply to our business? Oh, excellent question. Number one, I don't know what kind of business Viprika is referring to. Is it a retailer, a trader, or a manufacturing? But let me answer in a nutshell. Say if you are a manufacturer, but a small manufacturer who does not have the excess amount of capital, then 3D printing will reduce your capital expenditure while taking out highly engineered pieces. Number two, your turnaround time is faster. You can be closer to your customer, which means now you have a level playing field with bigger manufacturers in a sense. If you're a retailer, you don't have to now depend on a bigger manufacturers. You can have custom-made products, interacting with customers, creating a customer experience by having the printers in-house. I hope that answers your questions. Donesh Irani asks, what is the precision percentage of designs and how is calibration done for such machine? Okay, so in terms of SLA and digital wax, you can go up to 16 microns, and for DMLS, you can the wall thickness can be up to 0.3 millimeters. This is the piece that comes out of the machine. After that, it can be post-processed, it can go for mirror finishing, and it can go up to 1 micron, and I have seen products which go even sub 1 micron. I hope that answers the question. Donesh Irani again asks, how is these printers priced and do you have variance in this? Yes, printers are priced, have variable prices, depends on your usage and your product designs. You can ask this, you can get the information from me separately. My contact details are there. Yogesh Deshpande asks, how can I use the 3D printer to reduce my inventory? Okay, so I can say you're using the DMLS printer. Typically, to make these kind of designs, you would have to have your molds that requires real estate. Number two, the product, the raw material is in powder form, which means that you can just you don't need a high amount of inventory to be used in the machine. The machine uses exactly the amount required to build the piece, nothing in excess. Number three, this is additive manufacturing, not subtractive manufacturing, which is the conventional way of manufacturing. In conventional way of manufacturing, you would have a larger quantity of gold or precious metal, and then you need to have an inventory control. Here, the inventory is in a controlled environment and it is produced additively, which means there is negligible wastage. Viprika Jain again, what is the cost involved in manufacturing jewelry using 3D printing technology method? Viprika, this is quite an open question, a very wide question, because it depends on what kind of 3D printing is being used, what is the complexity of the design, and what is the material of choice. The cost involves are the capex varies. If it's an SLA, it's quite low, and it goes up to less than 100,000 euros for a DMLS machine. Bhavesh Shah asks, what do jewelry makers need to get started with 3D printing? Simple answer, contact Rootesh Shah. I'm just kidding. Okay. The jewelers, number one, is to have the vision to have 3D printing as a part of your sales process. I think that's the most important part. After which, designing is a key component. There are many people who can help you with designing. And last but not least, you can have consultants like me who can come on board and help you with the integration of 3D printing within your existing system. Viprika Jain again, is 3D printing process user-friendly, or is it compulsory for individual to create educational course for 3D printing? If you are already in the jewelry producing business, then I don't think it requires a lot. It requires, in my opinion, for a relatively intelligent person, it requires about 10 days training to get into the groove of 3D printing. Is there risk of losing the human element? Yes, Viprika, there is a risk of losing a human element, just like there was a risk in using a human element when computers were invented, mobile phones are invented, and so on and so forth. Yogesh Desai, maybe 3D is more economical when I produce a few pieces of the same design, but won't the traditional method of molds be more economical if I use it to, say, produce 50 plus pieces? Yogesh bhai, you're absolutely right, provided they are simple designs, and these designs are for the traditional way of manufacturing, be it investment casting or hand making. If the piece or the jewelry is designed for that sort of manufacturing, then you must go with the traditional method. However, the trick is to design for 3D printing. When you do that, it's impossible for the traditional method of manufacturing to produce the complex designs. Hence, in my presentation, in the slide where we did product planning, I mentioned in the very first point that if a design can be made with the conventional way of manufacturing, please do that and do not use 3D printing. 3D printing is design-oriented manufacturing, which means a person who owns 3D printing system needs to create designs that can only be done by 3D printing. When you do that, it's impossible or extremely difficult or very costly for traditional methods to replicate those designs. I hope that answers the question satisfactorily. Avesh Shah, what is the accuracy achieved during 3D printing and in traditional manufacturing methods? As far as SLA and digital wax goes, the quality of products is equivalent to investment casting or slightly more in terms of DMLS. Depending on the kind of post processes that you do, you could achieve quality far superior to investment casting. Does labor charges on jewelry get reduced due to 3D printing? Again, Bhavesh Shah. Okay, this is a googly. And I say that because you're assuming that you're going to make the same design that you would make for investment casting and 3D printing. Well, that's not going to work. Designs made in investment casting are designed for investment casting. The trick is to design for 3D printing. Once done, those designs would be very difficult or extremely difficult to make with conventional ways of making. So again, design is the key. Need to design for 3D printing. That gives you uniqueness of product which others can not copy and gives you an opportunity for better margins. Which are the latest 3D printing technologies used in the jewelry industry? Bhavesh Shah. Okay, I won't say latest, but SLA has been used for past 17-18 years to the best of my knowledge. The digital wax machine has been in the jewelry industry for past 4 to 5 years now. I'd like to continue with that answer. When you mention jewelry industry, Bhavesh bhai, I'm going to take world over, not just India. So DMLS is now being used extensively in developed countries because now they have started producing or manufacturing jewelry in-house, locally, and not depending on cheaper countries like India, China, so on and so forth. Ajay Marfatia bhai asks, is the piece more brittle than casted pieces? No, Ajay bhai, they are not brittle. In fact, DMLS is far more harder than the casted pieces. Mr. Latish Cheda asks, is 3D printing the future of fine jewelry? Absolutely. I agree with that. 3D printing is the future of fine jewelry, but that does not mean that handmade jewelry or plastic jewelry will not be there. I believe every technology has its own place. The trick is, or the more intelligent manufacturer will take the advantages of each manufacturing technology and try to have a synthesis, thereby creating hybrid technology, hybrid products using these technologies. Ajay Marfatia Bhai asks again, are you expecting an upgrade in the finishing and polishing methods? Yes, Ajay Bhai, that's a continuous process. So far, the finishing and the polishing methods used in DMLS are similar to the ones used in the investment casting. DMLS took such a leap in terms of technology that the ancillary industries that supports um, the main manufacturing has not been able to keep up. But now, slowly but surely, industries that manufacture machines for post processing are coming to terms with the DMLS. Mr. Latish Chera asks, what is the return period for a jeweler investing in a 3D printing technology? This is a quite an elaborate answer to this question and cannot be answered on this platform at this stage. And I'm not trying to avoid this question because truly it is. But let's put it this: SLA would have the best return on investments in terms of faster return on investments. However, say we take the other end, which is the DMLS, which is the most expensive machine as of now. If you invest in the design team and create products which are impossible to make in any other technology, then even DMLS can give you returns within 3 years. I know of manufacturers in Italy who are doing this, and they have an assembly line of 3D printing machines of 5-6 machines at a time. Ms. Anjali Sahane asks, how is 3D printing? How 3D printing is cost effective? Oh, Ms. Sahane, 3D printing is not cost effective if the design is made for handmade product or investment casting. It is extremely cost effective. It is made for 3D printing technology. Again, she asks, is 3D printing beneficial for both small scale and large scale production? Ms. Sahane, digital wax is extremely good, beneficial for large scale production. DMLS is extremely beneficial for small scale production. Mr. Harsh Gupta, hi, I want to start manufacturing jewelry. Currently, I am a jewelry designer. Which technology is ideal for me? Are there companies using this technology who I can outsource this job from? Yes, Harsh, you can do that. You can contact me separately and I can provide you with the necessary details. Mr. Deepak K asks, what would be the cost comparison with the existing method if I'm producing a few pieces of the same design, and the cost comparison if I'm producing 500 pieces same design? Deepak bhai, I will tell you right away. Same design that you use for investment casting, don't even compare it to 3D printing. It'll be expensive. You rather use the investment casting. The whole point is that designs are made keeping the manufacturing limitations in mind. Hence, designs that you use currently in the investment casting are designed for investment casting, not for 3D printing. If I would turn the tables around and make a design which can only be 3D printed, it would be very, very cost ineffective to do it in the traditional way of making designs, making products. Mr. Shreyans Chajjar asks, where can we get the training in Mumbai? Please ask me this separately on my email or call. I will guide you requisitely. Mr. Yogesh Desai again, what parts of jewelry can I make to 3D printer if I'm producing very intricate crafted Kalke jewelry? Will it really save any money? Yogesh bhai, I'm not aware of Kalke jewelry. I'll have to see the design and then we can have a conversation on that. I think we are done with the questions as of now. I'm free. I'm available for any questions on my email or my phone. More than happy to answer. Thank you very, very much for your time. Thanks.
Thank you, Mr. Shah, for having this very informative webinar for us today.
Thanks, Swapnil.
Thank you everybody for being such an active participants today and clarifying all your doubts. Still, in case if you have any questions, you can email it on the email address provided on the screen. And we look forward for your participation in furthermore many more webinars coming by GemAtlas. We are good to close for now. Thank you everybody for joining us today.